Welcome to our webinar today, and thank you for joining us. This webinar is brought to you by Codefresh Live, and today we are presenting Shifting Security Left with Prisma Cloud and Codefresh. Our presenters today are Vinay Venkataragavan, and he is the Cloud CTO of Prisma Cloud, and joining him will be Lindsay Smith, Cloud Security Systems Engineer at Palo Alto Networks. And today we're going to discuss and demonstrate the manner in which security teams can empower DevOps teams with the tools and capabilities to inject security into the CI/CD pipeline. And on that note, I want to go ahead and launch a poll before we get started so that we can give Vinay and Lindsay some information about who's joining today. So go ahead and answer that poll question for us, and that'll help us tailor the presentation a little bit. And while you're answering that, I want to go over some housekeeping notes. So we encourage you to ask questions throughout the session, but please enter them using the Q&A button on your Zoom toolbar. That helps us keep way better track of them, and we don't want them to get lost in the chat. So this session is being recorded, and don't worry, a copy of the recording will be sent to you by tomorrow from me, Taryn at Codefresh, so look out for that email. And also a copy of the slide deck here. Let's see, lastly, just please remember to check out codefresh.io/events. We have tons of upcoming webinars and virtual meetups on that page, so make sure and check that out as we have, informative webinars for you several times a month. And with that, let me go take a look at the poll questions, and I'll go ahead and welcome Vinay back. Hi, Vinay. I want to go ahead and read off the poll questions for you. Good morning. So we asked everyone if they were enacting some kind of security in their CI/CD pipeline today. About 29% said yes. We have 38% said yes, but they want to do more. 29% are working towards it, and 5% said no. So majority of people, 70% of people want more security in their pipeline today. And so hopefully that's why they're here.
Fantastic. That's a great segue. Thanks a lot, Taryn. And before we kick it off, I want to thank Codefresh for having us on. I think we have a very interesting session lined up for you all today. So with that, let's get started. Shifting security left with Prisma Cloud and Codefresh. My name is Vinay Venkataragavan. I'm the Cloud CTO for Prisma Cloud, and I'm joined with me by my colleague, Lindsay Smith, who's the Cloud Security Systems Engineer for Prisma Cloud. So I wanted to quickly spend a few minutes to lay the framework for what's happening in the industry today. I mean, it's no secret that the cloud is modernizing the software development lifecycle and the pipeline. And this is not only a technology transformation, but it's significant to recognize that this is also a people, process, and technology. And where is this all coming from, right? And I think it's fundamentally because enterprises recognize the need to move a whole lot faster than what has traditionally been afforded through the waterfall method. So they're adopting agile methodologies in order to bring innovative applications to the market much faster. So along with that, they also realize that with monolithic applications that are potentially vertically scaled, I mean, that's not going to cut it. So they recognize the need to actually break down these monolithic applications into independent microservices that are loosely coupled and deployed so that you have different teams that are able to move the needle and deploy code and their software into production environments at a much faster rate. However, the biggest benefit of these two changes and transformations is the ability to actually deploy code at a much more rapid rate. You know, gone are the days when, companies are actually deploying software twice a year on a 6-month software delivery life cycle. But now they're actually going to deploy software, on a weekly basis, dare I say multiple times a week, and dare I also say multiple times a day. So this is a tremendous shift that is happening in the industry today. And lastly, enterprises also recognize that automation and representing all aspects of your code and deployments and infrastructure as code is very, very important. Therefore, they're leveraging capabilities such as Terraform, CloudFormation templates, ARM templates, Google Deployment Manager templates to actually represent all aspects of their deployments as code and to operate and to leverage a common cloud operating model in order to have reproducible and repeatable and agile capabilities to deploy and bring these innovative applications to the market faster. Sounds fantastic. However, there are problems, and I'm going to talk about some of the problems that this has caused. So what you're seeing here is a cloud native deployment pipeline that has become very, very common in a lot of enterprises that are deploying cloud native applications, microservices, and containerized workloads across their entire application lifecycle. So it all starts at the build phase, where the DevOps teams, and it's both the developer and the operations teams working together, building infrastructure as code, building their application code, checking it into their SCM systems that triggers these build pipelines, builds these artifacts that are very commonly nowadays for microservices based architectures, your container images that go into a container registry, and then they have the ability to trigger different types of tests, unit system integration tests. And finally, when they're actually gone through all their application rigor, they actually deploy their software into their production environments on either Kubernetes or serverless platforms, as well as virtual machines. This is what I call the application stack, because most enterprises are on a journey. They have different types of artifacts that they leverage, which is VMs, containers, as well as serverless capabilities. Now, it's not all hunky-dory, unfortunately. And as we see this new paradigm taking effect with most of our customers and enterprises leveraging these capabilities, it's coming with it significant security challenges. So we talked about the fact that CloudFormation templates and Terraform templates are becoming very, very common and table stakes. However, a research survey conducted by our Unit 42 security team found that 42% of CloudFormation templates are insecure. So you can imagine now, when DevOps teams are leveraging these templates to deploy their code into production environments, this leaves them vulnerable to exploits and breaches, as we have seen, unfortunately, at many big organizations. And secondly, with the advent of containerization and Docker and open source technologies, as developers, and I'm going to wear my developer hat now, which is, when I'm developing my code, the last thing that I'm thinking about is security, because I want to make sure that I have all these capabilities, meet the features, and then I see the shiny new library that is sitting in a Docker hub or some kind of a registry somewhere, and I want to immediately incorporate it into my pipeline. I see a YAML file or a Docker file. Unfortunately, we found out that 51% of exposed Docker containers use insecure defaults. Once again, this leaves you vulnerable to exploits and breaches. And as we move to finally, from a compliance perspective, enterprises find it very, very hard to actually enact and enforce compliance in the cloud, because nowhere in the cloud would you find that here are, for example, the 37 security controls that you need to enact to be GDPR compliant or CCPA compliant or PCI compliant. So these are an example of some of the challenges that our customers are facing while actually dramatically increasing their cloud adoption, but security is as table stakes and they need to be addressed. So once again, let's just revisit all the security threat vectors for cloud native applications. So we talked about it. It starts at the Docker file. It starts with your infrastructure as code. So just to put it in context, from let's take a Terraform template, and I actually want to deploy a load balancer, and I want to deploy multiple VPCs. I want to deploy a database for all my persistent storage capabilities and needs. However, but it's very, very hard for DevOps engineers to know all the security controls and make sure that they've got them all configured appropriately. So I might leave my entire database open to the internet so that it can be accessed from anywhere in the internet, which is a security control that compliance standards call for, but which has not been addressed now. So that's a threat vector. My database is potentially not secure. So you need to make sure that your databases are encrypted. So those are all the problems. And then we also have these package repos where you're downloading new binaries, and they are fraught, unfortunately, with a whole bunch of vulnerabilities. And as you can see now, this is going through the build pipeline, and it's going to actually move into your deploy phase, where you're now going to actually use these artifacts to deploy your production environments. So your vulnerabilities are actually moving through through the build, deploy, and ultimately end up in the run phase, which is where you're ripe for being exploited. And it happens more often than not, unfortunately. So what is really needed is an integrated and a comprehensive approach where security is not bolted on. You know, security needs to be part and parcel of the entire application lifecycle throughout the build, deploy phase. I mean, gone are those days when development teams used to develop an application in isolation, throw it over to the security team for them to actually perform their scans, and maybe a couple of weeks later they come back, but the developers have already moved on, and so there's no appetite to actually fix these issues, and then you leave yourself once again vulnerable to exploits. So security has to be fundamentally built in, and it's more so important for cloud native applications because they are massively scaled. I mean, it's not an understatement to say that you have tens of thousands of containers for a complex application that is deployed, and good luck trying to secure it if you don't actually incorporate security throughout the build, deploy, and run phase. And we'll talk more about how we can make that a reality. And secondly, there is this traditional problem of trust between DevOps and security teams. And I know I smile because I know we have all been there, we've all seen it, where security teams just don't trust DevOps to get security right. And DevOps teams don't believe security understands the need for agility and how they work, and for them to actually have everything deployed in an automated manner. So there is a constant deadlock. So what really needs to happen is for security teams to have the visibility, establish the guardrails, but most importantly, empower DevOps teams with the tools and capabilities to incorporate security throughout the life cycle, once again, which is through their build, deploy phase. And this enacts far better security outcomes. And finally, change is the only constant. So what I mean by that is all of our cloud providers, even all the container orchestration platforms, are building features and new capabilities at a dramatic pace. So there is a need to actually normalize security, because you can't have point solutions for each of your capabilities, let's say either for your containers or for your virtual machines and for your serverless capabilities. Once again, there is no way to correlate across all these different asset classes and dimensions. So what is needed is a platform that can address security across the entire application stack. With that, when it's with the Prisma Cloud platform, we can actually enable our DevOps teams to actually have a DevSecOps posture by incorporating security throughout the build, deploy, and run phase. So for example, when we're going to have the most interesting part of this webinar is we've teed up a whole bunch of very interesting demos to actually show you how you can actually enact this in practice. But it's also, when I talked about it, it starts with the infrastructure as code. You have insecure configurations, but there are compliance standards that actually check for these security controls, which are out of the box using the Prisma Cloud platform. You can check for these right at the developer IDE. So for example, if you don't have versioning enabled for your S3 buckets, you can actually check that. And this is a very powerful capability, because as we all realize as developers and DevOps architects, that we would love to fix some capability when we're actually working on them, not at a later time when it's actually running in production and there is not as much of an appetite to actually make those fixes. So I'm happy to make these changes if I know what I need to address and how I need to address, and then the benefit there is far better security outcomes. So you can actually check for these capabilities in the build phase through the IDE, or even when you actually make a pull request. So there's a pre-commit hook, and we're going to show how the Prisma Cloud capabilities, along with the Codefresh platform, integrate security throughout the build, deploy, and run phases. So in the build phase, it's all about infrastructure as code scanning, instantaneous feedback to your DevOps teams to actually make the right changes. And now, as you progress into the deploy phase, you actually ensure that you scan all your container images in your registries based upon your enterprise security policies and the vulnerabilities, assess your risks, and make sure that you have policies to match the needs for your particular enterprises. So for example, an enterprise might have a policy that says, if an image has more than 2 critical vulnerabilities, it should never be deployed into production. So that can be enforced. So that image will never be promoted into your production environments. And in the deploy phase, you can also actually scan all your Docker and Kubernetes YAML files and manifests to ensure that you don't have insecure configurations. So let me give you a couple of examples. For example, you never want to have the root user exposed in your Kubernetes YAML files. You'd never want your containers, unless you absolutely have to run as a privileged container. And so there is a whole slew of compliance and security controls, for example, as defined in the NIST 800-190 special publication that was actually authored by Prisma Cloud, formerly it was formerly known as Twistlock, to actually showcase best practices for container security controls. And now we can actually scan and apply all of these security controls right at the deployment phase and fix a lot of these issues before it goes into production. And finally, in the run phase, you can actually have runtime security, automated policies that are learned and enforce capabilities to make sure that from a process, file, and network perspective, that your applications are doing the right thing, and then any kind of abnormal behavior is immediately flagged, giving your SOC teams and your DevSecOps teams the ability to have visibility into what's happening and remediation. So once again, if you want, I want you to think about the fact that containerized applications are deployed in the thousands. These are microservices and they're highly ephemeral. So all of these are incredible challenges. So you may need to make sure that you have the right security posture incorporated throughout, so that you're actually having defense in depth and progressively minimizing your exposure and affording a much better security posture for your applications in your production environments. So with that, I just want to spend one more minute talking about what a build pipeline for throughout a DevSecOps pipeline throughout the build deploy phase with security injected through looks like. So for example, we talked about IDEs, we've talked about your dependency repos, we're pulling all these different libraries and packages for all your different source code management systems, and then you're actually performing your SAST testing, and then you're also now making sure that security is a first-class citizen. It's not an afterthought. You're actually making sure that all your Kubernetes manifests are scanned, your infrastructure as code is scanned against security best practices, as well as your organization's compliance policies before they're actually pushed into your source code management system and or your image registries. Then in the deploy phase, you also want to make sure that you have stricter controls, because you also want to make sure that DevOps is not overly handcuffed. So you say, okay, we can have a looser set of policies in the build phase, but now in the deploy phase, we have tighter policies that you can now actually incorporate it throughout in your, for example, in the Codefresh platform as a custom step, where you can actually say, I want all my images to be scanned in the registry against my compliance standards. And I also want to make sure that all my infrastructure as code templates, as well as my Kubernetes manifest files, are scanned in different steps, applying different types of policies. And then only when they have actually successfully passed that step can they actually be deployed to the cloud. So let's talk about a couple of use cases and to see how we really enable DevOps to actually have a DevSecOps posture to actually harness both this Codefresh CI/CD platform and actually meet developers where they are. And an analogy which I love and which I've actually learned through numerous conversations with mature DevOps and DevSecOps teams is the fact that application developers want instantaneous feedback. The worst thing, a recipe for disaster, is bolt-on security, which means after the entire code has been deployed into production, security teams come back and say, hey, you need to go ahead and fix these 50 issues. And there's absolutely no appetite for that because they've moved on to the next capability. Sadly, that's the reality. So we want to change that. So we want to empower, security teams want to empower DevOps teams now by giving them that instantaneous feedback. And the way that can happen is, let's say, putting on my developer hat, I develop a piece of code and I push it into my GitHub repo. And then what happens is this immediately triggers a pipeline in Codefresh that goes and scans against all the different security policies. And if there are violations or if there are non-compliance, and if it actually doesn't meet the needs of the security teams, the build actually fails. And then you get very, very fine-grained feedback into what went wrong, what needs to be fixed, and how it can be fixed. That's very important. So now, which is very, very similar to, let's say a build fails because there is a memory corruption or a memory error or a unit test fails and the developer has to go fix it. Now we want to make sure that security and security testing is incorporated throughout the lifecycle. And this is how we do it. So when the pull request is made, and then it goes through the security compliance scanning capabilities for your templates, as well as for your templates in this case, it goes through. A developer fixes it. If it's passed, you merge the pull request, moves into your source code management. The next step of the build pipeline triggers, where now you want to scan your images that are pertinent to your applications across all the security compliance standards. It analyzes all the different vulnerabilities, and I showcase a view as to the information that one would get. So for example, it gives you a detailed analysis of all the vulnerabilities, the CVEs, the package that it's associated with, the version, as well as the severity. So now you can script policies according to the needs for your organization, as well as the risk appetite. As we all know, just because you have a vulnerability, that doesn't necessarily mean it has to instantaneously be fixed. It's all attributable to the amount of risk. So now vulnerability teams have full visibility into the packages that are being leveraged so that they can assess the risk and script the policies in the Prisma Cloud platform to suit their enterprise and their security operations needs. So similarly, if there are failures, they go back to the developer team, they need to fix those failures. And if all these tests have passed, then only do you actually deploy to the cloud. So I hope you see that there is a very, very systematic injection of security throughout the build phase, at the IDE phase, at the pull request phase, as well as in the deploy phase with the image scanning. And then this affords a tremendously improved security posture for your cloud native applications as they're deployed in production. And another significant point that I want to leave everyone with is, DevSecOps, it's been a very, very fancy term, and we don't look at it that way. We take it very seriously, and we want to help our customers make that a reality. And the very important part to recognize is it's not a discrete event. It's a continuous process of enforcement, measurement, improvement. So you identify, you respond, you detect, you adapt. So over a period of time, this affords security and DevOps teams to actually meet in the middle to have better outcomes, because they understand the security posture, they have visibility, they are able to track it, and now they're able to move the needle to have a far better secure posture as their applications are deployed in these production environments. One other use case that I wanted to highlight is the infrastructure as code and application as code scanning. What you see here is actually a overly simplified, this looks complex, but it's actually overly simplified production environment for one of our customers in the financial industry. And as you can see, this is an incredibly complex system, and it's fraught with potential problems. But now, with the ability to scan your infrastructure as code in either in your build and deploy phases, you can identify all these different misconfigurations and make sure that all of those security controls are applied appropriately. You have the right config options that have been set, which actually dramatically increases the security posture of your application as it's deployed in these production environments. And similarly, on the right, you see a large number of containers that have actually been deployed on AWS EKS and Fargate. But now you can actually scan. Once again, it's very important to recognize that you can actually identify all of these issues much prior to deployment, which was something that we could have only dreamed about maybe a couple of 2-3 years ago. So cloud native has completely changed the dynamics for enterprises, and now cloud native security also is able to come right along with it as a first-class citizen rather than as an afterthought. And finally, just another example of cloud security at the speed of DevOps, which is you have your application teams that are moving with great agility and moving very, very fast. But now with DevSecOps and SecOps and the ability to represent all aspects of your security as code, and now you're able to actually, security teams are now able to check in their security updates and their security policies and their security configuration changes into code that gets picked up by a Codefresh pipeline, because it identifies the Git triggers the changes, and then it goes through its own security tests and security processes and automatically gets applied into your environment. So that's the speed that we want everybody to operate with. DevOps is operating very, very fast, but security is not a laggard anymore. Security can keep pace. Everything is represented as code. We leverage the capabilities of platforms such as Codefresh, which gives tremendous flexibility in order to customize all the different steps to incorporate now security across the entire pipeline. So with that, I think it's time to put the money where my mouth is, and hopefully show you some real demos where you can actually showcase and surface all the different concepts that I talked about right now. I'm going to showcase a couple of demos, and I'm going to be joined by Lindsay, who's going to talk about how you can do image scanning throughout the Codefresh platform. So one of the concepts that I want to talk about is, here are my Terraform files, right? And I talked about the fact that developers now have the ability to have visibility into their code and the misconfigurations right in their IDE. So I have my Terraform files that I'm using to deploy an application into AWS, for example. But now I've configured the Prisma Cloud plugin in my IDE to be able to perform the necessary scanning. I've already configured all the policies on the Prisma Cloud platform, and they're immediately associated with my account. And then I'm just going to right click on one of my folders here, and I'm going to perform a Prisma scan. So what this does is this immediately triggers a scan, and I will have the results available right in my IDE. So for example, the Prisma scan has identified 2 issues that are non-compliant at the moment. So for example, it identifies the fact that, you know, your AWS S3 object versioning is disabled. That needs to be enabled, as well as you haven't enabled logging is disabled for your CloudTrail buckets. So let's quickly show how we can remediate it. I mean, I just want you to see that this is incredibly powerful. In live real time, I'm going to make these changes. I save my file. I go back to my code, and I'm now going to trigger a Prisma Cloud scan. So it identified the fact that versioning was not enabled. I've enabled it. It still found a couple of issues, but now you see my versioning issue is now gone. I've addressed my versioning issue. Similarly, I can address the fact that I can turn on logging for CloudTrail. But the point here is, right at the IDE, the DevOps teams have full visibility into compliance and misconfigurations, right? So we can make the changes. So the second demo that I would like to show you is, I have another two-tier application that I've deployed in AWS right now. And I actually want to make a few minor changes, for example, to actually show you that it triggers the, when I check in this code, it's going to trigger the Codefresh pipeline in order to detect and run the Prisma Cloud scans. So let's make a minor change to add some, just for the purposes of, to trigger the Codefresh scan. I'm going to make these changes. I'm going to commit it. I'm going to push it. So what happens is this gets pushed into GitHub, but immediately this will trigger the build pipeline on Codefresh. As we can see here, this is, let me refresh my screen here. There you go. This step is actually executing right now. It's cloning the repo, it's preparing the scan, and it's actually running the scanner. And now I will have the output of the scan. In a short second. So what's happening now is Prisma Cloud is now scanning all your Terraform templates, and it looks like it's identified some issues. So if we go in here, what happens is the Prisma Cloud scanning has identified that there are 2 high severity issues, 9 medium issues, and 1 medium issue. So you have the full visibility into what the policies are, what was the misconfiguration. So I actually know from this that one of my security groups is fully open to the world. So let's go and look at my Terraform file. So as you can see, what this tells you is my ingress for my security group is fully open to the internet, which is a big no-no. And so I'm actually going to go now, this is me as the DevOps persona. I'm going to go change it to say, hey, that was a bad choice. Now I'm actually going to make the change to say that I want to control who from the internet or which IP addresses can actually access my application, because I definitely don't want it to be world readable. So I want to make that change. Once again, I want to commit it. I want to push it, which should once again trigger a new build. There you go. It's triggered another build. This was just in progress. So we will see that it's actually now cloning and picking up all the new changes. And it'll once again run the scanner. And if you remember last time, we had 2 high severity issues. So hopefully, if I did this right, what we'll find is we've addressed one of those high priority issues. So the key point to notice here is that now DevOps teams have instantaneous feedback, just like their normal code reviews or some pre-commit hooks fail. Now security is addressed in the very, very same way. And then once we go and look at the output, previously I had 2 high priority issues. I understood that, my security groups are open. Now I've addressed one of them. Now I only have 1 high priority issue. So similarly, now you can see how you can actually have instantaneous visibility to your DevOps teams. They know what went wrong, how to fix it, they fix it, and then it moves through the pipeline. And so once I fix all my issues, you can actually push it through your additional steps and it goes through the progression. So with that, hopefully it gave you a sense of how you can incorporate infrastructure as code scanning and tie it to Git triggers into the Codefresh pipeline. You can have your steps and security scans executed throughout the pipeline, and it affords far better security posture and better outcomes for both DevOps and security. With that, I'd like to turn it over to my colleague, Lindsay, who's going to show us an exciting demo on how you can scan all your images through the Codefresh stack and pipeline.
Thanks, Vinay. Okay, so let me share my screen. Let's see. Yeah, when you stop sharing that, then I can share mine. Here we go. Let's see. Okay, you should be able to see my screen. So I'm going to kind of continue on the line that Vinay started. So where he showed you infrastructure as code scanning, I'm going to show you container build pipeline scanning. Conceptually very similar, the same sort of thing. I started with if you're a Codefresh user, this is just pretty much your everyday. So this is a very, let me go look at so super basic pipeline, clone, build, test, and push. This is what the wizard will give you for container build. And I'm going to switch to my protected pipeline. And so all I needed to do to get vulnerability and compliance scanning was add a few steps. So, and it's really just all boils down to this one adding this one step. So we have a binary called twist CLI that will do this image scanning for you. So we're having the container do it during the scan step. You can also do this from the command line as well if you want. That's pretty much it. So we're telling twist CLI scan this image. We're going to point it at a Prisma Cloud console, give it some credentials, and then this is the name of our image. And this is all in a code repo that we can share with you later if you want to drop in this step into your pipelines as well. But let's give this a run. This is going to be a little similar to what you saw with Vinay. So I'll go ahead and click on the output, and it's doing the usual stuff. Pull it down, build the image, and then it'll run our scan step. I like Vinay. I'm also come from a development background, and I think of all of this as, what shift left security means to me is hands-on keyboard time. It's like finding these things at the earliest possible moment where they're the cheapest to fix. It's if you can get feedback in 30 seconds and jump back into Vim and fix the issue and validate that it's done. That's way better than waiting for months, weeks or months to get some 1,000-page report from your security team of all the vulnerabilities that you need to fix. So, okay, so our pipeline is done. And I don't have a policy step, so it's always going to pass. I'm going to scroll up to the top, and we can kind of see what Prisma Cloud has told us. So all the stuff at the top, same as before, pull the repo, build the image, and then we run twist CLI runs a scan. And so this is the list. This is the detailed list of vulnerabilities that we've discovered. I think in the infrastructure's code, you were seeing the summary that would just say, 2 highs. This is the detailed summary. And so what we're getting here is the detailed information. So this is one of their what do we have? 2 criticals, I think. So we've got the CVE number, we've got its severity as critical, CVS scores. But from the developer's perspective, like this is what makes this useful and actionable. It's like, okay, so the Growl library has a problem. This version of Growl that comes from Node.js has this critical vulnerability. And here's my fixed version. So as a developer, I'm like, oh, this is pretty bad. We're using an old version of Growl. I'm going to go bump the version from 192 to 110.2 or something newer. I'm going to push that, and we're going to rerun the pipeline. And you rinse, repeat. And so we've just got it's a Node.js container. It's got a boatload of vulnerabilities. From the security side, do people actually address the mediums and lows? Generally not, but it is important that you focus on those criticals and highs and really understand, what are the ramifications of those things if they're running in production. So I'm going to scroll down the bottom, and we've also got a compliance section. And I'll note that if in a previous world, a very VM-based traditional infrastructure world, compliance often has a kind of a bad rap. It is involves audits and kind of nonsensical rules, and lots of them that are kind of confusing. In a world of containerized security, it feels to me a little bit different, where these are more practical suggestions of practices that you should be very mindful of. So where the vulnerability information is like this package that you've included has these vulnerabilities. These are more kind of runtime best practices that we could highlight to you. So this image was created with a non-root user. Not a great idea. Maybe you should have a different user creating these images. And then we get to kind of that same sort of summary to before. 2 criticals, 14 mediums, et cetera, and then you got some compliance information as well. And both of these were passes, and we'll come back to more about pass or fail in just a second. So I'm going to switch over to the Prisma Cloud GUI really quickly. So we built the front-end container. This is that front end right here. Prisma Cloud can kind of recognize your running containers, how they relate to each other, how they communicate with each other. And this is the one that we just scanned. And so as you saw, there was a lot of textual output in the pipeline. The information is there if you need it. Maybe not the most user-friendly there, but as an alternative, we have that same information kind of in a web presentation inside the GUI, and for what it's worth, there are roles that are meant for developers. Like they can log in, and basically this is the only information that they can see. So they can go in and get that targeted information for their containers that they're building, and they can get in. So you can allow them access to this kind of in a safe manner. But this is that same stuff. This is the that front end container that we just built. Here's our critical vulnerabilities. You can see, let's see, that's handlebars. We were looking at Growl. So that version of Growl, again, pretty old. Here's the fixed version. Here's a description of what the thing is, the review of the risk factors that kind of come with this thing. But again, this is pretty actionable for developers. It's like, oh, we need to bump the version, push that commit, and rerun the pipeline and see what we get, and then rinse repeat. We have similar information for compliance. So again, here's the image that we just built. Same sort of thing. Some a description of what this violation is and what you might want to do about it. So what you've got so far is we went from no feedback to instant good feedback in the pipeline, which is a big improvement. So well, then let's take the next step. So let's say that your organization, you've implemented this, you went from having no feedback, security feedback, to giving developers feedback. Maybe they're paying attention to it, maybe they're not, maybe they don't even notice it because it's in the pipeline output logs and builds are still passing. And so some time goes on and you say, you know what, I think we're ready to take the next step. And what we want to do is we want to have a policy where we do not allow containers with critical vulnerabilities to run in production, or pass CI. Either one of those cases. We don't. We're gonna raise the bar. So critical vulnerabilities won't pass CI pipelines anymore. So with Prisma Cloud, it's really easy to do that. And what we do is we in our parlance we call this we create a rule. So we're going to say fail builds with critical vulnerabilities. So new security policy. Okay, so by default, there's the alert threshold is everything. So in Prisma Cloud, alerts are just informational things that we log. That was every one of those that we scanned a container. It had X highs, X lows. That's an alert. It's informational, log forever. You can refer back to that. Failure threshold is what we want to focus on right now. So we're going to set, and by default, it's off. So everything is always going to pass no matter what. We're going to change this to critical. And so this will fail on vulnerabilities, or fail on builds with critical vulnerabilities. And we can scope this down. Maybe you only want it in your production environment. Maybe you only want it on a certain application. Whatever scoping you need, you can set that here. And again, like if you come from that sort of vulnerability management background, you know about how important exception handling is. So you can do all of that here. So, well, the rule is no critical vulnerabilities, but if there's no fix, maybe we'll turn this on and say, well, you can still build your containers during the period when there's no fix for the container or fix for the vulnerability. You can add exceptions if you want, either like explicitly by CVE, or you can add some exceptions based on time. But I'm going to save this. So I've got my fail builds with critical vulnerabilities. I'm going to go back. We're going to rerun this one and see what happens this time. And so we're running, and to reiterate, you can do this from the command line. You can do this here. We can scan images in the registry. We can scan them at runtime. You can also have runtime policies. You can say, no, we won't allow a container to start if it has critical vulnerabilities. There's a lot of flexibility and points at which we can integrate security. So it looks like our scan is about to run. Go ahead and maximize this. It takes, like 8-ish, 10-ish seconds. Okay, there we go. So as expected, it failed. And so you can see right here, scan failed due to vulnerability, policy violation, fail builds with critical vulnerability. So this is the rule that we just set up. And there's our 2 vulnerabilities. And this would fail. Let me get back. Yeah, so it will fail those builds. Yeah, these are protected, and you can see the our green passing and our red fail. So that's kind of what I want to show you. I want to show you one more thing really quickly. I just want to kind of reiterate the value of quote unquote compliance in a containerized world. So pretty similar to what you saw before. We can add an enforcement rule. So you could say maybe no high severity compliance issues, in running, and you could scope all this down. But John Morello, who's the CTO of Twistlock, which is the company that Palo Alto Networks acquired for the container image scanning, he's one of the 3 authors of NIST special publication 800-190, which is the container security recommendations from NIST. So he literally wrote the book on compliance. So a lot of this stuff here is just like, these are just good practices to keep in mind. Yet, yes, your security team might need to show this to auditors at some point, but a lot of this stuff is just like, in a containerized world, whether that's, the containers themselves, your Kubernetes or your Docker infrastructure, a lot of this stuff is just, good practices to keep in mind from an operational perspective. Things like, some of these things, it's like, don't put secrets in your environment variables, or don't embed, keys in images. These are the things that we can kind of detect and warn you about. And which a lot of what this is it's like, mistakes, intentional or unintentional, will make it through the system. And Prisma Cloud is really kind of good at finding those things. It's like, hey, you probably didn't know this, but this is something you might want to address, and we're good at finding those things. So in the new world of containers, I would say don't be as scared of compliance as maybe it was in the sort of traditional VM-centric world. And that's what I wanted to show. And so I'll kick it back to Taryn and Vinay.
Excellent. Thank you so much, Lindsay, for that awesome demo, and Vinay for your presentation and demo as well. If we want to switch back over to the presentation slides, that would be awesome, because I think we have a few offers for everyone, and then we will get to our questions. So we do have a couple questions that are in the Q&A, and I see that Vinay was able to answer many of those actually. So take a look at the Q&A. There were several questions about scanning Lambda functions in line, and yes, that is capable in Prisma. The Prisma Cloud is able to do that. And let's see, actually, I believe that all of them were answered in the Q&A here. So if anyone has any more questions or wants any more points of clarification, please feel free to enter those in the Q&A box. Let's see here. How about, Vinay, I mean, people talked about serverless. How flexible is Prisma Cloud, and how can you incorporate Prisma Cloud capabilities into the pipeline? Let's maybe summarize that.
Yes, absolutely. Great question. So we've taken an approach that we want to make it fundamentally very easy, right? So what that would mean is we wanted to integrate very closely with the Codefresh platform, where you have a plugin that is available for doing all the image scanning capabilities. So all you need to do is configure the plugin, connect it to your Prisma Cloud platform, and then you have all your policies that can be applied. And it's that simple to actually incorporate that into the a step into the Codefresh pipeline, right? So that's one. The second aspect is we also have a Twist CLI binary, as we call it, which is incredibly flexible. So a lot of teams sometimes you can't configure these plugins for every use case. So we say, okay, why don't you just take these capabilities and then cater it to your use case? So you can actually customize those steps by using the Twist CLI, which will actually scan all your infrastructure as code templates or your container images throughout the pipeline. So we take both approaches. So we want to make it absolutely easy and consumable to meet let's say 95% of the use cases for our customers. And I would want to say, with the Twist CLI binary incorporate into a custom step into a Codefresh pipeline, you can achieve most of your use cases. So we want to give that flexibility as well as ease of use, both options to customers across the maturity spectrum.
Excellent. And I just want to point out on our closing slide here, we have a great offer from Palo Alto Networks for their cloud native security report. I added that link in the chat if ever anyone wants to download that report. And a reminder, if you're not using Codefresh already, then you can sign up for a free account. It's free forever with unlimited builds, or schedule a one-on-one and we can help you get started at codefresh.io. So it looks like, yeah, most of those questions already got answered. Again, thank you so much, Vinay and Lindsay, for putting together this presentation and those awesome demos. I want to remind everyone that I'm going to send you a recording of this by tomorrow. So look out for an email from me, Taryn at codefresh.io, so you can share this recording with your coworkers and friends. I will launch just one final poll because we really do appreciate your feedback on the webinar, and make sure that we're describing it well and it's exactly what you expected. Feel free to email me back from the recording as well if you have any additional questions that come up after this. So thank you all so much for joining today. We hope to see you next time on Codefresh Live, and thank you again very much to Palo Alto Networks and Prisma Cloud. Have a great day.
Thank you.
Bye, everyone.